Hey tens! Today we're going to learn about the basics of inequalities. In previous videos, we were solving and graphing equations. Now we're going to write, graph, and later solve inequalities. Some terms to know. An inequality is a mathematical sentence that compares two expressions. An equation is a mathematical sentence that equates two expressions, but this one compares them. A number line is exactly what it sounds like, a line with numbers on it. You've probably seen them before. Just like in an equation, a solution is a value that makes the inequality true. A solution set is the set of all the solutions of an inequality, and I'll elaborate on this in the next slide. A closed dot is a solid dot, like a bullet point. It's used to symbolize that a value is included in the solution set of an inequality. And vice versa. An open dot is a circle, used to symbolize that a value is not included in the solution set of an inequality. And I'll show you how these look like in the next slide. And I'll show you how we use them when graphing inequalities on a number line in future slides. Okay, but when we're trying to write an inequality from a sentence, how do those work? When we are looking for words that mean less than, which is this sign, these are some words that are used in word problems. So these are the words that you want to look for when using the less than sign. When using the less than or equal to sign, you look for these words. For example, maximum, at most. At most is very popular when we're writing inequalities from word problems. Words used for greater than or equal to are minimum, more than or equal to, at least, no less than, not below. At least is also the most popular word used to symbolize that you're looking for greater than or equal to. And the words used for greater than are these. Now, let's see what is a solution and what is a solution set. If we have the inequality 8 is greater than 3, this is a true inequality because 8 is greater than 3. So 8 is a solution of this. So if we replace that 8 with a variable x, then 8 will be a solution because this makes the inequality true. But there can be infinite numbers that are greater than 3, so all of those numbers, the set of all of those numbers, let's take a few. 4, 3.01 is greater than 3. 78. All of these are greater than 3. And so this set is the solution set, the set of all possible solutions to this inequality. And so let's see what a closed dot looks like and what an open dot looks like. A closed dot looks like a bullet point. Simple. It's a circle just filled in. An open dot looks like a circle, which isn't filled in. So that's pretty simple. Alright, let's move on to the next slide. Writing inequalities from sentences. Let's try these examples. And before I show you how to derive the inequalities from these sentences, I encourage you to pause this video. Alright, I'm assuming that you're done and now you're waiting for me. So let's take the first one. A number is less than -4. how will we write this? We look for the keyword. And here, the keyword is, if you remember in the previous slide, less than. This symbolizes that a number, which is a variable, let's take n as our variable to symbolize number, is less than, so we take this symbol, -4. So this is our inequality that we get from this sentence. Alright, let's try the second one. A number can be at most 7. Alright, let's analyze the sentence and find the keyword that tells us which inequality we're going to use. And here our keyword is at most. Again, at most stands for less than or equal to, because if something is at most a number, it can be equal to that number or less than that number. It cannot be greater than that number. So a number, let's take n again, can be at most less than or equal to 7. So this is our inequality for this. Alright, let's move on to the next slide. Let's graph inequalities. And how do we graph inequalities? We use a number line. And yes, I forgot to show you what a number line looks like. So I'll just draw one right up here. A number line is basically a line. You draw both arrows to symbolize that this line goes on forever in both directions, and then you just add numbers on it. So this can be any number. Let's just put that as 1, 2, 3, and this can even be 40 over 4, 5, I don't know. It just has to be in a sequence. So if 40 over 4 is greater than 5, and it is, 40 over 4 cannot be in between 3 and 5. So it has to be logical order. Okay. So I'm just going to erase that example. Alright, let's take the first example. And before I show you the steps, again, I encourage you to pause this video. Alright, I'm assuming that you're done. So let's start with the first one. X is greater than -8. So I have just constructed a number line right here. And let's label it. Let's put -8 in the middle. So I'm just going to put -8 right here. And remember, it can be any place in the number line because these go on forever. And we're going to label the ones next to it. So if we're going to the left, the numbers decrease. If we're going to the right, the numbers increase, as you've probably heard before. So I'm just going to label that. Okay, so now I have the number line labeled. And so we see this greater than sign. And what this means is when there's no greater than or equal to or less than or equal to sign, when it doesn't have this dash underneath it, it means that this value, -8, or any value that's a constant and not the variable, this value is not going to be included in our solution set. And what that means is we use an open circle to symbolize that. So on -8, we need to put an open dot to symbolize that -8 is not going to be in our solution set. And how do we show that x is greater than -8? Well, we use an arrow, but which direction do we point the arrow in? A nice tip is that wherever this thing is pointing, like an arrow, you put the arrow that way. You see it? So we make an arrow all the way here. This is going to be infinite. So that's our graph of this inequality. And I'll just erase that. So this is our graph of x is greater than -8. Okay, let's take the second one. X is less than or equal to 6. And I have another number line right here. So let's label the number line. I'll just put 6 right here. Okay, now I have the number line labeled. And first we see whether or not this inequality sign here has a dash underneath it or not. And we see that it does. So it means that 6 is going to be included in our solution set. And that's represented by a closed dot, or that bullet point dot. So we put a bullet dot on 6. And by bullet dot, I mean the closed dot. Now, which way do we point the arrow in? Again, that tip is to go whichever direction this point is going in. So we put our arrow this way. And again, this goes on forever. So that's our graph of x is less than or equal to 6. Thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, please put those in the comments below. And remember, the comment section is the equivalent of a class discussion, so if you have answers to any of the questions, you can answer them. If you have any suggestions as to how I can improve my future videos, or even what I should do next, put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one.